Hi guys, let's start a new chapter. It's called linear inequations in one variable. So let's look at something which is what we've already done. We've already done how to solve simultaneous equation. We've done how to solve quadratic equations. So equation is of the form x is equal to 3y, which means obviously if we are talking about linear, the power is obviously 1, that's the maximum power, and there is an is equal to sign in the middle. Now that's an equation. And any equation is of the form x is greater than something, x is less than something, or 3x is more than or equal to, or x is less than or equal to. So these are inequations in two variables. So they have two variables because they have the variable x and y. And the last one which I have listed here, which is 2x plus 7 is more than 3, is linear inequation in one variable. So in this chapter and in class 10, we will focus only on linear inequations in one variable. So this is the kind of question that we'll be working on. Let's move on. Now, how to solve linear inequations? Exactly the same way that we solved equations. Exactly the same way, but there are minor changes. As and when the changes come, I'll let you know. So let's look at one of the first one. If I have an equation which is x minus 4 is more than 7. So if this equation was x minus 4 is equal to 7, well, I am allowed to add 4 on both the sides, which means this would become x is equal to 11. Some people also say, write this in the form that take negative 4 on this side, so this becomes x is equal to 7 plus 4. This is what we did in equations. Exactly the same logic and rule is applicable in inequations, which means you can add the same number on both sides, which means x minus 4. If I have to remove this negative 4, I add 4 here and I add 4 on the other side as well, which means x is more than 11. I can also look at this the same way, which means if I take negative 4 on this side, the sign changes, which means it becomes x is more than 7 plus 4, which means x is more than 11. So I can add the same number on both sides. Let's look at the second property, which is I can subtract the same number on both sides. So if I have an inequation which is x plus 4 is more than or equal to 9, then what it means is I can subtract 4 from both sides, which means this is what I get. I subtract 4 and this gives me x is more than or equal to 9 minus 4, that's 5. Now this can also be looked at the way I would look at it in an equation, which means if I take positive 4 on this side, the sign changes and it becomes negative. So it was positive, on the other side it becomes negative. So this becomes x is more than or equal to 9 minus 5 or 9 minus 4 rather. 9 minus 4, which means x is more than equal to 5. Done. So these two properties exactly the same as equations. A third one is where there is a small change. In an equation, you can divide and multiply both sides by any number except 0. In this case, that rule is applicable only if you're doing it with a positive number. Let's look at an example. So in this case, if this is x divided by 3 is more than 7, if I multiply both sides by 3, what I get is x is more than 21, which is exactly what I would do in an equation as well, which means if I take this 3 on this other side, if this is division sign here, it becomes multiplication, which means this becomes x is more than 7 into 3. Same thing for dividing. I can divide both sides by 2 if I want to remove the 2 from here, which means x is less than 2. I could have done the same thing, which is take 2 on the other side and would have become x is less than 4 by 2, which means x is less than 2. So these three rules are exactly the same. In this case, this is possible only with a positive number. Let's look at what happens if I multiply or divide by a negative number. So if I multiply or divide by a negative number, this is the major change between an equation and an inequation. The sign of inequality changes. To understand this, let's look at this particular example that I've given. X is more than 3. Let x be equal to 7. Yeah? Let's, for understanding sake, let x is equal to 7. So if I multiply both sides by, let's say, negative 2, this becomes negative 2x and this becomes 6. If I multiply both sides by negative 2, this becomes negative 14 and this becomes 6. Sorry, negative 6. If I'm multiplying by both sides, this becomes negative 6. If I'm multiplying by negative 2 here and negative 2 here, similarly, to look at a real number example, let's multiply by negative 2. So I have negative 2x and negative 6, negative 14 and negative 6. What should be the sign in the middle? Is negative 14 less than negative 6 or more than negative 6? Yes, negative 14 is less than negative 6, which means if I multiply the same number on both sides of an inequation, the sign in the middle, which is the sign of inequality, changes. Right now it was a greater than sign, it became a less than sign. So this is negative 2x is less than negative 6. So negative 2x is less than negative 6. Let's look at this example with a division. This is what I had multiplied. So let's divide both sides by negative 2. Let's divide both sides by negative 2. This becomes negative x and this becomes negative 2. Let's look at this with a real number. So 12 divided by negative 2 gives me negative 6. 12 obviously is more than 4. 12 divided by negative 2 is negative 6 and 4 divided by negative 2 is negative 2. Now which is the bigger number? Yes, negative 2 is the bigger number. So negative 6 is less than negative 2. Similarly, negative x is less than negative 2. So that's why in case you are dividing by a negative number, then the sign of inequality changes. And then the last rule, which is if x is more than y, then 1 by x is, yes, less than y. Let's look at an example. Let's say if I have 10 is more than 5, which means 1 by 10, which is equal to 0.1, and 1 by 5, which is equal to 0.2, which is bigger. Yes, 1 by 5 is bigger. So if you are taking the reciprocal of both sides, then the sign in the middle, which is the sign of inequality, changes. So key difference here is if you are multiplying or dividing by a negative number, then the sign of inequality changes. That's the key major difference. Let's look at solving some questions. Okay, so let's look at question. So I am on exercise 4a. Let's look at question number 3, part 1. So this is the question. Quick revision. X belongs to n. This is how you read this. N is natural number, which is 1, 2, 3, 4 and go on. W is whole number. We've done this earlier in earlier years. Just a quick revision. Z or I, some people write Z, sometimes they write I, is basically integers, and the last one, which is R, is real number, which means all numbers including fractions, all of them would come in real numbers. All these natural number, whole number and integers can be written in the, when you're writing a solution, they can be written in the set builder form, which is where you write it in English, and they can also be written in the form of listing method, which is you write the specific numbers which are answered. R, which is real numbers, is only written in set builder form. Now in case you are confused, when we solve questions, I will come back to it. So hold on to this thought. If you have N, W or I, then they can be written in either of the forms. Ideal would be list the answer, but in case of real number, your answer will obviously only be in set builder form. So if x belongs to natural number, we need to solve this. So let's apply, let's take 2x on this side of inequality and 3 on this side of the inequality. So this is 5x minus 2x is less than equal to 18 minus 3, which is 3x is less than equal to 15. Let's take 3 on this side, which means I'm dividing, which means x is less than equal to 15 by 3, which means x is less than equal to 5. So that's my answer. X belongs to natural number. So that's my answer. X belongs to natural number and x is less than equal to 5. This is my solution set, which is x. It's a solution of all x such that x is less than equal to 5 and x belongs to natural number. Now this is the set builder form that I was referring to. Easier way of writing it, this SS is basically solution set, would be if you list the number. So natural number less than or equal to 9, less than or equal to 5 would be 1, 2, 3, 4 and 5. Simple. Right? So that's the final answer. This is the listing method that I was referring to. So you list it. This is because x belongs to natural number. Let's look at question number 4, part 2. It says if x belongs to whole number and 3x minus 1 is more than 8, we need to solve this equation. So some people also write this as x, the replacement set, which means the set from which you are looking at replacing the value of x. So replacement set for x is whole number, is w. Right? So some people also write this as replacement set. In case it's not written as x belongs to whole number, don't get confused. Replacement set is nothing but the set from which you can have the value of x. So let's solve this question. So if this is 3x minus 1 is more than 8, I take negative 1 on the other side, which means this becomes positive. So it becomes 3x is more than 8 plus 1, 3x is more than 9. I take 3 on the other side, it becomes division sign. So this is x is more than 9 upon 3, which means x is more than 3 and x belongs to whole number. Now this is my solution set written in a set builder form. I would always prefer to write it in the listing method. Is x is more than 3, which means 4, 5, 6. Since it's more than 3, which means it's going up to infinity. Quick reminder, if you put 3 dots, minimum 3 dots are required to portray that the numbers are ongoing and do not end at 6. So you put 3 or 4 dots, and which basically means that the number is going up to infinity. Writing your answer in the solution set form is the best way of answering. Let's look at the next question. Question number 4, part 4. It says if x is equal to, if x again is a part of whole number, and this is the equation, 7 minus 3x is more than equal to negative half. So as in personal choice, I always keep my x as positive. I always keep my x as positive so that I don't end up having to change the sign of the inequality. So I always would try and keep my x positive. So I take negative 3x on this side and I bring negative half here. So this becomes 7 plus half is more than or equal to, and I take negative 3x on the other side, it becomes plus 3x, which means this is 7.5, which is 15 by 2 is more than equal to 3x, which means 15 upon 2 into 3 is more than or equal to x, which is 3, 1, 3, 5, which means 2.5 is more than or equal to x. Now to write your answer, this means solution set is x is less than, if I read it from here, x is less than or equal to 2.5, which means the possible values of x are 0, 1 and 2, since we are looking at whole number. So the first whole number is 0, 1, 2, 3, but 3 would be more than 2.5, which means my solution set is 0, 1, 2. So that's my solution set for this question. So let's look at the next one. The next one that we are doing is question number 4, part 6. It says if x belongs to whole number, 18 less than or equal to 3x minus 2. So let's take negative 2 on this side, becomes 18 plus 2 is less than or equal to 3x, 20 is less than or equal to 3x, which means 20 upon 3 is less than or equal to x, which means 20 upon 3, that's 6 2 by 3 is less than or equal to x, which means x is more than 6 2 by 3, which means solution set is more than 6, which means 7, 8, 9, and this is whole number, which means it's going up to infinity. So that's my solution set. Next question. The next question that we do is question number 7, part 3. It says if replacement set is a set of real number. So here the question is mentioning a replacement set. What it basically means is x belongs to R. In this case, real numbers. So this is the question. 5 plus x by 4 is more than x by 5 plus 9. So x by 4 is obviously more than x by 5. So I take x by 5 on this side and I take 5 on the other side, which means x by 4 minus x by 5 is more than 9 minus 5. Let's take LCM. So this becomes 5x minus 4x upon 20 is more than 4, which is x upon 20 is more than 4, which means x is more than 80. And x belongs to a real number. So if you need to write your solution set, you will write your solution set as it's a set of all x such that x is more than 80 and x belongs to R. That's your final answer. It's a set of all x such that x is more than 80. Some people also write this as with 2 dots, which means solution set is it is a set of all x such that x is more than 80 and x belongs to R. Let's look at question number 7, part 4. Again, it's a replacement set and it's a set of real numbers. So x belongs to R. Let's cross multiply both sides, this side by 5, this side by 8. So this becomes 5x plus 15 is less than 8x minus 24. Like I said, I always prefer to keep my x positive, which means I take 5x on this side, negative 24 on this side. So this becomes 24 plus 15 is less than 8x minus 5x. 24 plus 15, that's 39, is less than 3x, which means 39 upon 3 is less than x, which means 13 is less than x, which means x is more than 13. So let's write the final answer in the form of a solution set. It's a set of all x such that x is more than 13 and x belongs to a real number. That's your final answer. That's your final answer that I'm highlighting for this question as well. And this is the final answer for question number 4, part 6. Let's look at the next question that we do. The next question that we do is question number 8. Question number 8 says, find the smallest value of x for which 5 minus 2x is less than equal to 5.5 minus 5 by 3x. So, and x is an integer. I did not write. X belongs to integer. So let's solve this and see how we will get about this. So negative 2x is more than, or rather 2x is more than 5 by 3, which means I should take negative 2x on the other side. So to keep my x positive, and I get 5.5 on this side. So this is 5 minus 5.5 is less than equal to 2x minus 5 by 3x. This is 5 minus 5.5 is negative half is less than or equal to 6x minus 5x upon 3. I've taken the LCM, which means negative half is less than or equal to x upon 3. What it means is x upon 3 is more than or equal to negative half. Writing the same thing but another way, if I cross multiply, what it means is x is more than or equal to negative 3 by 2, which means x is more than or equal to negative 1.5. So what are the values of more than equal to? Have I written the question incorrectly? Let me just check. Question number 8. Yes, I have written the question incorrectly. This is not more than equal to. The question is only, this is only less than. Now it doesn't have the equal to sign, which means this sign goes, which means this sign goes, this sign goes, which means x by 3 is just more than, x by 3 is more than negative half, x is more than negative 1.5. So since this is integers, which means my solution set for this would be, solution set is any number, any integer which is more than negative 1.5, which would be, so x has to be more than 1.5. The question is smallest value, which would be more than 1.5, would be -1. So is -1 is equal to x. In case the smallest value was not given, if I had to find the value of only integers, my answer would have been, solution set for this would have been -1, 0, 1, 2, and goes on, right? Because this is integers. But the question is smallest value, which means one value which is the smallest. So the smallest integer which will satisfy this inequation would be -1, because -1 is more than -1.5. So that's the smallest integer. Next one, question number 9. Let me just check if I have written the question correctly. 2 times x minus 1 is less than or equal to 9 minus x. Perfect. Let's look at this question. So let me open the bracket first. So this becomes 2x minus 2 is less than or equal to 9 minus x. Let's take negative x on this side, -2 on this side. So this becomes 2x plus x is more than or equal to 9 plus 2. 3x is less than or equal to 11. X is less than or equal to 11 upon 3, which means x is less than or equal to 2 upon 3. So x has to be smaller than 2 by 3. And we are looking at the largest value, which means x would be the largest possible value of x would be x is equal to 3, because we are looking at whole numbers. In case this element of largest was not given, my solution set would have been more than x is less than or equal to 3, which means whole number, which means 0, 1, 2, 3. That would have been the solution set in case largest was not there. Since largest is given, the largest possible value is 3. That finishes this video for me. Let me just mark a couple of homework questions for you. Homework question would be question number 11 and question number 12. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.